On October 29, 2025, just 2 days before Halloween, the interstellar object known as 3I/Atlas will sweep to within about 203 million kilometers of the Sun, a moment astronomers call perihelion, the instant when a traveler from the stars dives deepest into our neighborhood before climbing back toward the dark between suns. For planetary scientists, it is a rare alignment of orbital mechanics. Yet for thinkers who study the boundary between science and possibility, it is also a mirror reflecting how little we still understand about visitors from beyond. When I first heard of 3I/Atlas, my thoughts flashed back to Oumuamua, discovered in 2017, the first known interstellar object to cross our system. Oumuamua spun like a flattened shard, glinted oddly in sunlight, and most mysteriously, accelerated as though pushed by a gentle continuous force, even though no outgassing plume was detected. That anomaly led me to propose a controversial idea, that Oumuamua might be artificial, a thin fragment or light sail, perhaps crafted by another civilization. The notion was met with both fascination and skepticism, but it reminded the public that humility before the unknown is a scientific virtue, not a weakness. Now 8 years later, 3I/Atlas approaches, moving along the ecliptic plane where planets and spacecraft circle like dancers in a vast celestial waltz. Its timing, its orientation, and its predicted brightness curve once again strain the limits of coincidence. If nature has twice delivered an interstellar body whose motion brushes the same orbital plane that human technology occupies, we must at least allow the question, is this geometry accidental or intentional? At perihelion, the Sun's gravity acts as a natural accelerator, capable of multiplying velocity through what engineers call a gravitational assist. Every major deep space mission, Voyager 1 and 2, Galileo, Cassini, New Horizons, even the Parker Solar Probe, has used this trick to save propellant and gain speed. An advanced species could employ the same principle on a far grander scale, steering probes between stars by surfing gravitational wells. If 3I/Atlas were equipped with any propulsion mechanism, the instant of closest approach would be the ideal time to fire it, when a small impulse could translate into a massive trajectory change. Paradoxically, that is the exact moment when Earth cannot see it. From our vantage point, the object will pass behind the Sun, hidden in blinding glare. Our telescopes, optical and radio alike, will be effectively blind. For a few crucial days, the universe itself closes its curtain, leaving us to wonder what happens backstage. This coincidence, if it is a coincidence, makes the event both scientifically tantalizing and faintly unsettling. Together with Omer El-Dadi and Gershon Tenenbaum, I co-authored a white paper urging governments to treat such anomalies as potential black swan scenarios. Extremely rare, yet immensely consequential occurrences whose neglect could cost humanity the chance either to protect itself or to learn something revolutionary. The paper calls for an international rapid response system, space-based infrared telescopes, radar arrays, and data-sharing protocols to ensure that the next interstellar object is never lost in solar glare. As I explained recently to Bill Hemmer and Dana Perino on America's Newsroom, this is not alarmism. It is preparedness. Hemmer asked, "Avi, are you suggesting this could be built?" And I answered, "I'm suggesting we shouldn't dismiss what we don't yet understand." Dana smiled and said, "That sounds like a scientist's version of trust but verify." And she was exactly right. Curiosity without verification is fantasy. Skepticism without curiosity is blindness. The coming weeks offer a test of whether modern science can hold both in balance. Observatories in Hawaii, Chile, the Canary Islands, and orbiting platforms like the James Webb Space Telescope are already coordinating to record every measurable photon before and after perihelion, hoping to capture subtle variations in light curve, spin rate, and infrared signature. If 3I/Atlas behaves like an ordinary comet, developing jets of sublimating ice, shedding dust, following the expected gravitational path, we will celebrate a triumph of observation. But if it behaves otherwise, if its acceleration fails to match natural models, if its albedo changes sharply, if it splits or turns or simply vanishes into a vector that defies prediction, then history may pivot on how seriously we pay attention. Some dismiss such speculation as sensational, but sensational simply means worthy of the senses. Science begins in sensation, in noticing that something does not fit. The Galileo project at Harvard, which I founded after Oumuamua's discovery, embodies that philosophy. To apply rigorous, transparent, repeatable methods to phenomena once dismissed as fringe, from unidentified aerial data to interstellar anomalies. 3I/Atlas will be one of our key subjects. Early spectroscopic readings suggest mixed ices and silicates typical of comets, yet its approach velocity relative to the Sun implies an origin beyond the local bubble, perhaps from a region shaped by ancient supernova shocks. That distance alone is enough to humble any assumption of familiarity. For an object to traverse light years of interstellar medium and arrive intact implies either incredible luck or purposeful trajectory. Consider that our own Voyager 1, after nearly 50 years, is only now entering interstellar space at a fraction of 3I/Atlas's speed. Nature, it seems, occasionally outpaces technology. But what if technology sometimes masquerades as nature? In antiquity, the Trojans accepted a wooden horse as a gift, unaware it carried soldiers within. The analogy is imperfect but instructive. Appearances can mislead civilizations. If an extraterrestrial probe were designed to study young technological species discreetly, the simplest disguise would be the most common object in space, a comet. I am not claiming this is so. I am claiming it is testable, and therefore worth testing. The real danger lies not in being wrong, but in refusing to look. When we ignore anomalies, we impoverish discovery itself. 100 years from now, historians may judge our era not by the number of exoplanets we cataloged, but by whether we dared to confront the evidence that challenged our preconceptions. In a sense, 3I/Atlas is less a mystery about the cosmos than a mirror for the human mind. Do we see pattern where there is only randomness? Or do we overlook design because we fear ridicule? Humility demands that we entertain both possibilities. The sun will blaze unperturbed as 3I/Atlas swings around it, and for a brief moment our telescopes will fall silent, our data streams blank. Yet in that silence, imagination must take the place of sight. Perhaps nothing unusual will happen. Perhaps somewhere behind the solar fire, a faint signal will pulse and go unnoticed. Either way, our response should be the same. Watch, measure, learn. Humanity stands at a threshold similar to that faced by early navigators who first saw unknown sails on the horizon. To look away was safer in the short term, but progress belongs to those who looked through their spyglasses and dared to ask what might lie beyond. The universe has already sent us 2 messengers in less than a decade. We can treat them as accidents or as invitations. Whether 3I/Atlas is a lump of primordial ice or an emissary of intelligence, its arrival reminds us that the cosmos is not a static museum, but a living conversation. The question is whether we are willing to listen. As scientists, we must remain disciplined. As humans, we must remain curious. Between those 2 poles, discipline and curiosity, lies discovery. When the light returns and our instruments once again find the tiny point of 3I/Atlas receding into darkness, let us remember that understanding begins not with certainty, but with the courage to wonder. The universe rewards attention, and perhaps, if intelligence truly travels among the stars, it rewards humility as well. Yet humility must be paired with action, for if 3I/Atlas slips away unexamined, we lose not only a data point, but a chance to measure ourselves against the vastness that made us. The next time an interstellar object enters our system, it could come closer, faster, or harbor phenomena that challenge our physics outright. Already, engineers have proposed sending rapid launch interceptors, small autonomous craft kept in standby orbit that could sprint toward future visitors within days, capturing images and samples before they depart forever. The technology exists. Only the political will lags behind. Policymakers hesitate because budgets are finite. Yet every generation invests in the tools that define its destiny. The telescope for Galileo, the rocket for the 20th century, and perhaps the interstellar probe for ours. If 3I/Atlas teaches us anything, it is that complacency is the real alien among us, invisible, comfortable, and deadly to discovery. I often tell my students that the universe is under no obligation to make sense to us, but we are under every obligation to try. Our ancestors once feared comets as omens. Today we can fear only our own indifference. Somewhere, light from distant suns is still traveling toward our eyes, carrying messages written in the language of physics. Whether we decode them with humility or ignore them with arrogance will decide how history remembers this moment. 3I/Atlas may turn out to be ice and dust, but its true gift is philosophical, a reminder that the boundary between the natural and the artificial is drawn by knowledge, not by distance. When future astronomers look back on the early 21st century, I hope they will see a species that refused to look away, that, even when blinded by the sun, kept listening for a whisper from the dark. For in that whisper may lie the next great chapter of our cosmic story, and the proof that curiosity, not fear, is humanity's oldest and most enduring engine.